step aside lithium-ion EV batteries. You've been made obsolete by a piece of ceramic that could double your range and charge you in the time it takes to grab a coffee. Enter solid-state batteries. This isn't just a battery upgrade, it's a complete re-engineering of the entire EV architecture. Today we're tearing down the hype and the reality of solid-state batteries, or SSBs. What they are, why they're the actual future of EVs, and why the current battery chemistry is dead on arrival. We'll show you the three global giants fighting tooth and nail for dominance. If you own an EV, plan to buy one, or just enjoy watching billions of dollars get poured into a global high-stakes technology war, you need to see who's winning and how soon your next car will be a 1,000-kilometer monster. Stick around, because the industry's dirtiest secret about the commercial timeline is at the end. Let's start with the boring reality of today's electric cars. The battery pack is essentially a giant tank of energy, but what makes the energy move, the electrolyte, is a flammable, liquid, organic solvent. Think of it like a highly volatile, sloshing pool of juice inside the cells. This liquid is the source of all your anxiety. It's heavy. All that liquid requires a massive, complex cooling system. More weight equals less range. It's slow. You can't charge it too fast, or you risk dendrite growth, little lithium spikes that stab through the internal separator, causing a short circuit and, you guessed it, thermal runaway. That's battery fire, folks. And it has an energy ceiling. Current lithium-ion cells top out around 250 to 300 watt-hours per kilogram. That's your range limit. The solid-state battery replaces that risky, sloshing liquid electrolyte with a solid. Usually it's a wafer of ceramic, glass, or a stable polymer. Why are they different? First, safety. The solid material is non-flammable. You can stab it, heat it, and it will not combust. We're talking virtually fireproof batteries. Firefighters worldwide will cheer just at this point. Lithium-ion batteries can burn for hours in thermal runaway and require tens of thousands of liters of water just to bring under control, only to reignite days later due to heat trapped deep inside the armored pack. Second, energy density. Because the solid electrolyte is so much more stable, manufacturers can finally use a pure lithium metal anode. Lithium metal stores exponentially more energy than graphite. While your current battery is stuck at approximately 250 watt-hours per kilogram, the SSB is aiming for 400 watt-hours per kilogram or more. That's the difference between a 450-kilometer car and a 1,000-kilometer car, using the exact same size battery. Third, charging. Remember those dendrite spikes that slow down charging? The solid material is physically strong enough to block or suppress that growth, enabling charging times that can hit 10 to 80% in under 10 minutes. The switch to a solid is a game changer. In short, SSBs are safer, lighter, faster charging, and higher density. They fix every single major issue with today's EVs. So who is actually closest to delivering this magic? This is a toe-to-toe international slugfest with no guaranteed winner. We can divide the frontrunners into three main camps. Toyota is the tortoise of the race, slow and steady, allegedly. Toyota has been working on this longer than anyone and holds the most patents. It's focusing on the highly complex sulfide-based solid electrolyte, which offers the best performance but is notoriously difficult to manufacture. It hates moisture. Toyota has partnered with materials giant Idemitsu to conquer the supply chain challenge. It is targeting initial vehicle deployment around 2027 to 2028. When Toyota finally releases something, expect it to be a bulletproof, perfected product, not a beta test. QuantumScape is the disruptive high-tech rockstar, backed heavily by Volkswagen, is using a completely different, high-risk, high-reward approach called an anode-free ceramic separator. It has demonstrated incredible lab results. 10 to 80% charge in under 15 minutes with high cycle life. Crucially, the company has successfully delivered its most advanced B1 samples to its automotive partners for testing. This is the stage where the cells move from the lab bench to being built into actual car packs. This transition is usually where science goes to die, so watch this space very closely. Speed, scale, and a state mandate define the Chinese ecosystem. Unlike the West, Chinese companies don't fight solo. They work as a powerful, coordinated ecosystem with government policy pushing hard. In January 2024, the Chinese government launched the China All-Solid-State Battery Collaborative Innovation Platform, or KSIP, to bring together bitter commercial rivals, including CATL, BYD, GAC, SAIC, and various academic and government research institutions. The purpose? To pool resources, solve foundational R&D challenges, set standards, and establish a complete domestic supply chain for solid-state batteries by 2030. This level of mandated high-level cooperation among competitors is rare in Western and Japanese markets. Companies like GAC and its partners have thrown down a major gauntlet, announcing the completion of pilot production lines for automotive-grade, large-capacity cells over 60 ampere-hour. They aren't waiting for perfection. GAC is already planning small-batch vehicle integration in its hypermodels as early as 2026, aiming for that mythical 1,000-kilometer range claim. Their strategy is to get the product out the door now and iterate faster than the competition. So, who wins? The slow, meticulous patent king Toyota, the slick, high-performance American startup QuantumScape, or the Chinese ecosystem focused on sheer volume and speed? The answer is, it doesn't matter yet, because the biggest challenge isn't the chemistry, it's the manufacturing cost. Remember all those claims of 2025 and 2026 deployment dates? Here's the eye-opener. Those are almost always semi-solid state batteries, a hybrid compromise that still uses some liquid to make it easier to manufacture. The true, all-solid 400 watt-hour per kilogram fireproof miracle battery. The industry's quiet consensus, away from the marketing press releases, suggests that true, cost-competitive, mass-market adoption won't happen until closer to 2030 or even 2032. Every car you see advertised today promising a revolution in the next 2 years is probably just selling you a slightly better version of the old problem. The real holy grail is still hiding a little further down the road.